Hello and welcome to the first lesson of DC motor course. I hope you have understood the DC generator, you have good knowledge about DC generator, and after that you are starting with the DC motor. But if you are starting without understanding the DC generator, then I will strongly recommend you understand the DC generator first and then come back to DC motor, right? That will be beneficial for you. Now let's start with the principle of DC motor. As we know, motor converts electrical energy into mechanical energy, right? As an input, we give electrical energy to the motor, and then as an output, we get mechanical energy. So input, let's say we are connecting a battery to the motor as an input. That means we are giving electrical energy. And as an output, when we connect the battery to the motor, the shaft of the motor starts rotating, right? And that means the electrical energy is converted into mechanical energy. That rotation represents the mechanical energy. However, in case of DC generator, it is exactly opposite. In case of DC generator, we are providing mechanical energy as input, and then as an output, we are getting electrical energy, right? Now, let's look at the principle of a DC motor. Let's take two permanent magnet N and S pole. Now these permanent magnets will produce their own magnetic field, which you can see on your screen. Now in this magnetic field, if we place a conductor which is carrying electric current, it will experience a force, right? What we are doing here, we have taken two permanent magnets N and S, which is creating their own magnetic field. And in that magnetic field, when we place a current carrying conductor, it experiences a force, and because of that force it starts rotating. So the principle, we can say, when a conductor carrying current is placed in a magnetic field, it experiences a force, right? Clear? Understood? What we have done, two magnets which are creating magnetic field. In that magnetic field, we have placed a conductor which is carrying a current. And because of that, it will experience a force, and that force will cause the rotation of that conductor. Clear? Now in the image shown, or in the condition shown, the conductor may not rotate in a circular direction because we have not provided the correct arrangement for that. But when we provide the correct arrangement, it will be rotating perfectly in the circular manner. So as you see, we need two main components to produce a DC motor. One, we need the magnet and magnetic field, and second, we need a conductor who is carrying current. Now it should carry current. That is very, very important. Remember that. Not only conductor, but a conductor which is carrying current. Now a question can arise, okay, everything is happening fine. We are putting a conductor in magnetic field and it is rotating. But how to decide in which direction the conductor will rotate, right? That is the question, and that is important question. Unfortunately, to find that out, we have Fleming's left-hand rule. By using Fleming's left-hand rule, we can find the direction of motion of the conductor. Now, before you understand what is Fleming's left-hand rule, let me tell you the hand position for left-hand rule. So, take out your left hand and make a thumbs up, right, like this. And from the thumb, your index finger should be creating a 90-degree angle. So you have to open the index finger like that. It will create a 90-degree angle with the thumb like this. Here you can see it is creating a 90-degree angle. Now in next step, you have to open your middle fingers like that. It should create a 90-degree angle with your index finger. So like this. Now here you can see your middle finger is creating a 90-degree angle with the index finger, and the index finger is creating a 90-degree angle with the thumb. So this is how you can put your hand in order to understand the left hand rule. Now the Fleming's left hand rule tells us that if the index finger represents the direction of magnetic field from N to S pole, then the thumb will indicate the direction of force which will act upon the conductor, and the middle finger indicates the current. Understood what is happening? If your index finger is indicating the magnetic field pointing towards N and S pole, then the thumb will indicate the direction of force which will act upon the conductor, and the middle finger indicates the direction of current. So that is left hand rule used to find out the direction of rotation of conductor in case of DC motor. Now, a lot of people get confused between Fleming's right hand rule and left hand rule. Please make one thing clear in your mind, that Fleming's right hand rule is used to find out the direction of current in case of generator, whereas Fleming left hand rule is used to find out the direction of force which will act upon the conductor in case of motor, right? So that is the differentiation between the Fleming's left hand rule and Fleming's right hand rule. Keep a note of that. Now let's quickly summarize this lesson. When a conductor carrying current is placed in a magnetic field, it experiences a force. Now this is the basic principle on which our DC motor operates. You have to remember this very clearly. This is very important. Then the next is, we need two main things in order to make a motor, that is magnetic field system and the current carrying conductor. To find out the direction of motion in DC motor, we can use Fleming's left hand rule. Now this was just one demo class. The course on DC motor, which is available on the Electrical Guy mobile app, consists of a lot of such videos, lot of such easy to understand videos. Now what all the things covered in the course, I've given that down in the description. You can check that out, or you can simply visit www.theelectricalguy.in to know more about the course. I hope you found the video helpful, and if you did, do click on the like button and do share the video with your friends. That's all I ask. That's all for this video, guys. I'll see you in my next one. But till then, keep watching, keep learning.